Hello everyone, welcome back to my channel and welcome back to my series Learn with Me Data Science. I am Anshika Verma and here is the 8th video of the series Clustering. So clustering is a fundamental technique in data science that involves grouping similar data points into clusters based on their characteristics, allowing for identification and patterns, structures and relationship within the data. It is an unsupervised learning method that helps to uncover hidden insights and categorize data into meaningful subgroups. Clustering is widely used in data science applications such as customer segmentation, image recognition, and gene expression analysis. Now let's jump to the Python implementation of clustering. So this is the code for clustering, starting with importing libraries and generating the data. So firstly, we are importing the libraries, NumPy library for numerical computation, matplotlib.py, plot for plotting, and importing the make blobs function for from sklearns database module to generate synthetic data, and at last importing the k-means class from sklearns cluster module but not used in this snippet. So we are starting with generation of data. X comma dash equal to make blobs generate synthetic data using make blobs. N sample equal to 300 generate 300 data points. Center equal to 4 uh, generate centers for clusters. Creates 4 clusters. Cluster dash STD equal to 1.0 sets this standard deviation of each cluster is 1.0 and random state 42 sets the random seed for reproducibility. Now we are visualizing the data. Plt.scatter plots the data points using matplotlib scatter function where x colon comma 0 and x colon comma 1 creates the extracts the x and y coordinate from the data. S equal to 50 sets the marker size to 50. Plt.title data distribution sets the plot title to data distribution and plt.show displays the plot. Here is the output of the code, which is a scatter plot that displays the distribution of synthetic data generated by the make blobs function. Here, a 2D scatter plot with 300 data point is representation by a small dot. The data points are clustered into 4 distinct groups, with each group having a roughly circular shape. The clusters are relatively well separated with some overlap between them, and the data points within each cluster are randomly distributed with a standard deviation of 1.0 as specified in the make blob function. So the plot provides a visual representation of a synthetic data, which can be useful for verifying that the data generation process is working correctly, getting a sense of the underlying structure of the data, and identifying potential issue with the data such as outlier or uneven cluster distribution. So overall, the output plot is a simple and effective way to visualize the synthetic data and gain insight into its property. Now we are applying k-mean clustering. So k-mean equal to k-mean and cluster equal to 3 random state 42 create a k-mean clustering model with 3 cluster which is k equal to 3 and set the random seed for reproducibility. Why k-mean equal to k-means dot fit predict x fits the k-mean model to the data x and predict the cluster labels of for each data points. Now visualize cluster. In this, plt.scatter plots the data points with the color corresponding to their cluster labels. And plt.scatter plots the centroid cluster center as a red dot with a larger size. And plt title sets the plot title as k-mean clustering. And plt.legend display a legend for that plot. At last, plt.show function displays the plot. of the output of this code plot shows the k-mean clustering result with data point colored according to their cluster labels as we see. Red dot representing the centroid centers 1, 2, and 3 of the center, a legend indicating the centroid. This plot helped visualize the clustering result, allowing it to see how the data points are grouped into cluster, identify the cluster, evaluate the quality of the clustering result. The number of cluster was chosen arbitrarily in this example. In practice, you may need to try different value of k and evaluate the result cluster using matrices such as Chilhot score and Linsick-Hurwitz index. Now we are moving to the next part, which is choosing the optimal number of cluster. Here we are using elbow method for choosing k. Inertia equal to inertia initialize an empty list to store the inertia value. K range defines a range of k from a value from 0 1 to 9, and for k in k range loops, starting loops through each k value in the range. uh, K means equal to K means n cluster equal to K random state 42 creates a K mean clustering model with K cluster and sets the random set for reproducibility. K mean dot fit x fits the K mean model to the data x. Inertia dot appends the inertia value of the K mean model to the inertia list. Now plotting the elbow curve. PLT dot plot plots the inertia value against the k value with markers at each data point. PLT dot title sets the plot title as elbow method. PLT dot x label and PLT dot y label sets the x and y axis label. And at last, as always, PLT dot show function displays the plot. So the output plot is an elbow curve which shows the relationship between the number of clusters and the inertia value. The elbow curve is used to determine the optimal value of k and k-mean clustering. So the inertia value decreases as k increases and indicating that the k-mean model is fitting the data better with more cluster. The rate of decrease in inertia slows down as k increases, indicating that the additional cluster are not providing much additional value. The elbow point where the rate of decrease is inertia changes indicate the optimal value of k. This is the point where the additional clusters start to provide diminishing returns. By examining the elbow curve, you can determine the optimal value of k for your k-mean clustering model. Now moving to the next part, which is evaluating the clustering. In this, firstly we are importing the Silhouette score function from skitlearn's matrix module, and uh, starting with the code which calculates Silhouette score. So here Silhouette score x y k mean calculates the Silhouette score for the k mean clustering results. X is the original data and Y k-mean is the cluster label assigned the k-mean algorithm. And print function prints the score with two decimal places. The Silhouette score is a measure of how similar an object is to its own cluster compared to other clusters. The score ranges from -1 to 1, where a high score close to 1 indicates that the object is well matched to its own cluster and poorly matched to neighboring clusters. The low score, which is close to 0 -1, indicates that the object has been assigned to the wrong cluster, and a score close to 0 indicates that the object is on a very close to the decision boundary between two neighboring clusters. By examining the Silhouette score, you can evaluate the quality of the k-mean clustering result and determine whether the cluster are well separated and cohesive. So the output, which is Silhouette score equal to 0.76, indicate that the K-mean cluster result has a very high level of cohesion and separation. So the score is close to 1, which indicate that the object is each in each cluster are very highly similar to each other cohesion, and distinct from object is other cluster which is separation. The score is not exactly one, which suggests that there may be some overlap or ambiguity between the clusters, and the score is significantly higher than 0, which indicates that the key K-mean algorithm has done a good job of identifying meaningful clusters in the data. In general, a Silhouette score of 0.76 can be interpreted that the cluster are well separated and cohesive, with a clear distinction between objects and different clusters. The objects within each cluster are highly similar to each other, with a strong sense of cohesion. The K-mean algorithm has done a good job of identifying the underlying structure in the data. So overall, a Silhouette score of 0.76 suggests that the K-mean cluster result is of high quality and can be trusted to provide a meaningful insights into the data. So this is the old code for clustering. In this way, you can do clustering on your data. That's it for this video. Meet you in my next video, which is on the topic regression modeling. Till then, keep smiling, keep exploring. Bye bye.